NFPA 70E is the National Fire Protection Association standard for electrical safety in the workplace. It provides comprehensive guidelines for electrical safety, including risk assessment, hazard identification, and personal protective equipment, abbreviated PPE, requirements for working on energized electrical equipment. Arc flashes are extremely hazardous events that can cause severe burns and other injuries. NFPA 70E mandates the use of proper PPE to mitigate the risks associated with arc flashes. Types and levels of PPE required are determined based on an arc flash risk assessment. Type 2 fuses are designed to clear faults quickly and limit arc flash energy. They are an important part of an arc flash mitigation strategy, as they can help reduce the severity and duration of an arc flash event. OSHA, the Occupational Safety and Health Administration, enforces NFPA 70E as part of its electrical safety regulations. Employers must comply with NFPA 70E requirements to ensure the safety of their employees working on energized electrical equipment. Attending a seminar on arc flash safety can be highly beneficial for individuals involved in electrical work. These seminars provide valuable information on arc flash hazards and their potential consequences, NFPA 70E's requirements for PPE, risk assessment, and arc flash mitigation, best practices for preventing and responding to arc flash incidents, the importance of compliance with OSHA regulations, and real-world case studies and examples. NFPA 70E is a critical standard for electrical safety in the workplace. Its emphasis on PPE Type 2 fuse protection and OSHA enforcement highlights the importance of recognizing and mitigating the risks associated with arc flashes. Seminars on arc flash safety are highly recommended for individuals involved in electrical work, as they provide valuable knowledge and guidance to ensure the safety of workers and compliance with regulatory requirements. Electrical safety in the workplace is paramount, and understanding standards like NFPA 70E is crucial for preventing accidents and ensuring compliance with regulations. Arc flash, a dangerous phenomenon, can result in severe injuries, highlighting the importance of protective measures. Firstly, let's delve into the risk assessment process. This involves identifying potential electrical hazards and evaluating the likelihood and severity of potential injuries. Secondly, hazard identification is essential. Recognizing potential sources of electrical hazards, such as exposed conductors, faulty equipment, or improper grounding, is the first step in mitigating risks. Personal protective equipment, PPE, plays a vital role in safeguarding workers from electrical hazards. It includes items like insulated gloves, arc-rated clothing, and face shields, providing a barrier against potential harm. Proper PPE selection is crucial, ensuring it meets the specific requirements for the task at hand. Type 2 fuses are a key component to an arc flash mitigation strategies. These fuses are designed to quickly interrupt electrical current during fault conditions, limiting the energy released in an arc flash event. The fast response time of Type 2 fuses minimizes the potential for damage and injury. OSHA's enforcement of NFPA 70E underscores the importance of compliance. Employers are responsible for providing a safe working environment, adhering to NFPA 70E guidelines, and ensuring their employees are properly trained. Compliance with OSHA regulations is not just a legal requirement, but also a moral obligation to protect workers. Seminars on arc flash safety offer valuable insights into the complexities of electrical safety. They provide a platform for learning about arc flash hazards, understanding NFPA 70E requirements, and exploring best practices for prevention and response. These seminars often include real-world case studies, illustrating the potential consequences of neglecting electrical safety and the effectiveness of mitigation measures. Arc flash hazards encompass a range of potential dangers, including severe burns, electric shock, and even death. The intense heat and pressure generated by an arc flash can cause significant damage to equipment and infrastructure. Understanding the potential consequences of arc flash is essential for promoting a culture of safety in the workplace. NFPA 70E outlines specific requirements for PPE, including arc ratings, which indicate the level of protection provided by the equipment. Arc ratings are expressed in calories per square centimeter, representing the amount of heat energy the PPE can withstand. Selecting PPE with appropriate arc ratings is critical for ensuring adequate protection against arc flash hazards. Risk assessment involves evaluating factors such as voltage levels, fault currents, and working distances to determine the potential arc flash hazard. This assessment helps identify the appropriate level of PPE and other safety measures needed to mitigate risks. Arc flash mitigation strategies aim to reduce the likelihood and severity of arc flash events. These strategies may include implementing engineering controls, such as installing arc flash relays and current limiting devices, as well as administrative controls, such as developing safe work practices and providing employee training. Best practices for preventing arc flash incidents include energizing equipment before working on it, using proper grounding techniques, and maintaining equipment in good condition. Regularly inspecting electrical systems and components can help identify potential hazards before they lead to accidents. Responding to arc flash incidents requires a coordinated effort, including providing immediate medical attention to injured workers, investigating the cause of the incident, and implementing corrective actions to prevent future occurrences. A thorough investigation can help identify underlying issues and prevent similar incidents from happening again. Compliance with OSHA regulations is essential for ensuring a safe working environment. OSHA conducts inspections of workplaces to verify compliance with safety standards and may issue citations and penalties for violations. Employees who fail to comply with OSHA regulations may face significant fines and legal liabilities. Real-world case studies provide valuable lessons learned from past arc flash incidents. By examining the causes and consequences of these incidents, organizations can identify areas for improvement in their electrical safety programs. Case studies often highlight the importance of proper training, PPE, and adherence to safety procedures. Type 2 fuses offer superior protection compared to other types of fuses due to their fast response time and current limiting capabilities. These fuses are designed to interrupt fault currents quickly, minimizing the energy released during an arc flash event. The use of Type 2 fuses is a critical component of a comprehensive arc flash mitigation strategy. The selection of appropriate PPE depends on the specific hazards present in the work environment. Factors to consider include the voltage levels, fault current, and working distances involved in the task. A thorough risk assessment is essential for determining the appropriate level of protection needed. Employee training is a vital component of any electrical safety program. Training should cover topics such as arc flash hazards, NFPA 70E requirements, PPE selection and use, and safe work practices. Properly trained employees are better equipped to recognize hazards and take appropriate precautions. Regular safety audits and inspections can help identify potential hazards and ensure compliance with safety regulations. These audits should be conducted by qualified personnel who are familiar with electrical safety standards. Addressing any identified hazards promptly is essential for maintaining a safe working environment. Engineering controls, such as arc flash relays and current limiting devices, can help reduce the likelihood and severity of arc flash events. These devices are designed to automatically interrupt electrical current during fault conditions, minimizing the energy released. Implementing engineering controls is a proactive approach to arc flash mitigation. Administrative controls, such as safe work practices and procedures, can also help prevent arc flash incidents. These controls may include developing lockout/tagout procedures, establishing safe work zones, and requiring the use of insulated tools. Adhering to safe work practices is essential for minimizing the risk of electrical accidents. The development and implementation of a comprehensive electrical safety program requires a commitment from all levels of the organization. Management support is essential for providing the resources and training needed to ensure a safe working environment. A culture of safety should be promoted throughout the organization, emphasizing the importance of following safety procedures and reporting hazards. Continuous improvement is essential for maintaining an effective electrical safety program. Regularly reviewing and updating safety procedures, providing ongoing training, and incorporating lessons learned from past incidents can help improve safety performance over time. Staying informed about the latest developments in electrical safety standards and technology is also important. Organizations should actively participate in industry groups and attend conferences and seminars to stay up to date on best practices. Investing in electrical safety is not just a cost, but an investment in the well-being of employees and the long-term success of the organization. By prioritizing safety, organizations can reduce the risk of accidents, improve productivity, and enhance their reputation. NFPA 70E provides a framework for establishing a comprehensive electrical safety program. By following the guidelines outlined in the standard, organizations can create a safe working environment and protect their employees from electrical hazards. The standard is regularly updated to reflect the latest advances in technology and best practices. It is important to stay informed about the latest revisions and incorporate them into the electrical safety program. Arc flash is a complex phenomenon that requires a thorough understanding of electrical safety principles. By investing in training, PPE, and mitigation strategies, organizations can significantly reduce the risk of arc flash incidents. A proactive approach to electrical safety is essential for protecting workers and preventing accidents. The use of technology can also play a role in improving electrical safety. For example, infrared cameras can be used to detect hot spots in electrical equipment, which may indicate potential problems. Remote monitoring systems can also provide real-time data on electrical system performance, allowing for early detection of anomalies. Collaboration between employers, employees, and safety professionals is essential for creating a safe working environment. By working together, organizations can identify hazards, develop solutions, and promote a culture of safety. Open communication and a willingness to learn from each other are key to success. Electrical safety is an ongoing process that requires continuous vigilance and improvement. By prioritizing safety, organizations can create a workplace where employees are protected from electrical hazards and can perform their jobs with confidence. The benefits of a strong electrical safety program extend beyond the workplace. Employees who are trained in electrical safety are also more likely to practice safe electrical habits at home, protecting themselves and their families from electrical hazards. Electrical safety is a shared responsibility that benefits everyone. By working together, we can create a world where electrical accidents are rare and everyone is safe. The information provided in this discussion is intended for general guidance only and should not be considered a substitute for professional advice. Consult with qualified electrical safety professionals for specific recommendations tailored to your situation. Always follow applicable electrical safety codes and regulations. Improper electrical work can be dangerous and may result in serious injury or death. If you are not qualified to perform electrical work, do not attempt it. Contact a licensed electrician for assistance. Remember, safety is always the top priority when working with electricity. Take the time to understand the hazards involved and follow proper safety procedures. By doing so, you can protect yourself and others from harm. Type 2 fuses, in particular, offer enhanced short-circuit protection compared to standard fuses. This is due to the specifically designed construction that facilitates rapid arc quenching and current limitation. The internal structure and filling materials of Type 2 fuses contribute to their superior performance in quickly interrupting fault currents and reducing the energy let through during an arc flash event. This design consideration is crucial in minimizing equipment damage and preventing severe injuries to personnel. The selection and application of Type 2 fuses require careful consideration of the specific electrical system characteristics, including voltage rating, current rating, and interrupting capacity. It is imperative to consult manufacturer specifications and relevant industry standards to ensure proper fuse selection for optimal protection. Regular inspection and maintenance of Type 2 fuses are also essential to verify their integrity and functionality. Damaged or improperly installed fuses may compromise their protective capabilities and pose a significant safety risk.